The Messerschmitt Me 262 was a revolutionary aircraft that forever changed the way the world thought about aerial combat. It wasn't just fast. It was a glimpse into the jet-powered future of aviation at a time when most fighters were still propeller-driven. When it entered operational service for Germany in 1944, it instantly captured the imagination of both its pilots and its enemies. With speeds far exceeding those of any Allied piston-engine fighter, the Me 262 could engage enemy bombers with impunity and often outrun chasing fighters, creating a dramatic shift in the dynamics of air combat. Its very existence forced the Allies to rethink their strategies and demonstrated the potential of jet propulsion in military aviation. The heart of the Me 262's performance lay in its jet engines. Unlike propeller-driven aircraft, which were limited by the mechanical efficiency of their props and the drag created at high speeds, the Me 262's Junkers Jumo 004 turbojets provided continuous thrust that allowed the plane to reach speeds of over 540 miles per hour. This speed advantage was unprecedented at the time, allowing Me 262 pilots to choose when and where to engage in combat, often diving onto formations of bombers with little risk of immediate interception. It was a game-changer, as even the fastest Allied fighters struggled to keep pace or mount effective attacks. However, speed alone didn't guarantee success. Jet technology was new, engines were temperamental, and the aircraft required careful handling to avoid catastrophic failures during takeoff, landing, or sustained high-speed flight. Operating the Me 262 was a challenge. Its engines were delicate, with limited service life, and any mishandling could lead to failure. Pilots had to master a completely different style of flying compared to traditional propeller aircraft. Acceleration and deceleration behaved differently, and high-speed aerodynamics presented new challenges in stability and control. Nevertheless, for those who could master it, the aircraft was unmatched in its ability to strike and retreat at will. German pilots could dive on heavily escorted bomber formations, deliver devastating firepower, and then climb back into the sky before Allied fighters could effectively respond. This tactical flexibility made the Me 262 a formidable weapon despite its relatively small numbers. The Me 262 also carried heavy armament that complemented its speed. Most models were equipped with four 30mm Mk 108 cannons, capable of tearing through bomber hulls with devastating effect. Some were fitted with R4M air-to-air rockets for long-range attacks, allowing pilots to engage multiple targets in a single pass. The combination of speed and firepower meant that a single Me 262 could inflict significant damage and escape before counterattacks could be organized. Its performance created a new standard for what fighters could achieve, forcing both sides to reconsider tactics and the future of aerial combat. Despite its advantages, the Me 262 came too late and in too few numbers to change the overall outcome of the war. Germany faced production difficulties, fuel shortages, and Allied bombing raids that limited its operational deployment. Even with its technological superiority, it could not compensate for the overwhelming numbers and logistical dominance of the Allied forces. Yet, the Me 262 left an undeniable mark on aviation history. It proved that jet propulsion was not only feasible in combat but superior to traditional designs in speed, climb rate, and tactical versatility. The legacy of the Me 262 extends far beyond World War II. It inspired post-war jet fighters on both sides of the Iron Curtain and demonstrated the future trajectory of military aviation. Its combination of speed, firepower, and innovative engineering made it a glimpse of the jet age to come. And it remains one of the most iconic aircraft ever flown. Pilots who mastered it described it as exhilarating yet demanding. A machine that rewarded skill and courage while reshaping the air war in ways that were previously unimaginable. The Me 262 was more than a fighter. It was a symbol of innovation, speed, and the dawn of a new era in aerial warfare. The P-51 Mustang is often remembered as one of the most iconic American fighters of World War II. And its reputation for speed, agility, and long-range capability made it a game-changer over the skies of Europe. Unlike the Me 262, which relied on jet propulsion, the P-51 was a piston-engine aircraft. Yet its combination of design innovations and aerodynamic efficiency allowed it to match and, in some cases, surpass the performance of many contemporary fighters. What truly set the Mustang apart was not just its raw speed, but its ability to escort Allied bombers deep into enemy territory. A role that proved crucial in gaining air superiority and weakening Germany's industrial capacity. One of the most important aspects of the Mustang's design was its laminar flow wing, which reduced drag and improved high-speed performance. Combined with the Packard-built Rolls-Royce Merlin engine, the P-51 could reach speeds exceeding 440 miles per hour and maintain impressive maneuverability, even at high altitudes. This combination allowed pilots to engage enemy fighters effectively while maintaining the endurance necessary for long missions over hostile territory. The Mustang's speed gave it a tactical edge, allowing pilots to intercept enemy aircraft, disengage when necessary, and perform hit-and-run attacks with remarkable precision. The long-range capability of the P-51 was perhaps its most revolutionary feature. Before the Mustang, Allied bombers flying deep into Germany were vulnerable to attacks from Luftwaffe fighters because escort fighters simply didn't have the range to accompany them all the way. The Mustang changed that equation entirely. With drop tanks, it could escort bombers from England to targets as far as Berlin and back, ensuring that Allied bomber formations were protected throughout their missions. This dramatically reduced bomber losses and allowed for sustained strategic bombing campaigns that crippled German infrastructure and shifted the balance of air power in favor of the Allies. The P-51 also excelled in versatility. While its primary role was long-range escort, it could also perform ground attack missions, strafing enemy convoys and providing close air support to advancing Allied forces. Its 6.50 caliber M2 Browning machine guns packed significant firepower, and combined with its speed, the Mustang could take on enemy fighters and ground targets with lethal effectiveness. Pilots appreciated how responsive and reliable the aircraft was, often praising its combination of performance, endurance, and handling that allowed them to engage in both dogfights and precision strikes. Beyond its technical attributes, the P-51 Mustang had a psychological impact on both sides of the conflict. Allied crews flying under its protection felt more confident, knowing that they had a capable and fast escort throughout their missions. On the German side, Luftwaffe pilots feared the Mustang for its combination of speed, altitude performance, and relentless presence over their airspace. It became clear that the Mustang was not just another fighter. It was a force multiplier, capable of shaping the air war in ways that few other aircraft could match. The success of the P-51 Mustang wasn't just about individual performance. It was also about strategy. Its ability to maintain high speeds over long distances, combined with its maneuverability and firepower, allowed Allied commanders to plan complex operations with confidence. The aircraft's reliability and ease of maintenance meant it could be deployed in large numbers, sustaining pressure on enemy forces and ensuring the Allies retained air superiority during critical campaigns like the Normandy invasion and the strategic bombing of German cities. Ultimately, the P-51 Mustang was a perfect example of how design, speed, and strategy can come together to create an aircraft that dominates the battlefield. It may not have had the raw velocity of the Me-262, but its combination of agility, range, and tactical versatility made it one of the fastest and most influential fighters of World War II. The Mustang didn't just participate in the war. It changed it, giving the Allies the tools they needed to control the skies and paving the way for future generations of high-performance fighter aircraft. The Supermarine Spitfire is one of the most iconic aircraft of World War II, and by the time the Mk14 variant appeared, it had evolved into one of the fastest and most formidable fighters of the conflict. While earlier Spitfires were already celebrated for their agility and speed, the Mk14 introduced the powerful Rolls-Royce Griffon engine, giving the aircraft a significant boost in performance that allowed it to compete with the latest German fighters, including the formidable Focke-Wulf FW-190. This upgrade transformed the Spitfire from an exceptional fighter into a high-speed predator, capable of taking on any opponent in the skies over Europe. The Mk XIV's performance was a game-changer. With top speeds exceeding 440 miles per hour at altitude, it could chase down or evade almost any German aircraft it encountered. Its enhanced climb rate and acceleration meant that pilots could engage on their own terms, diving or climbing to gain tactical advantage before the enemy had a chance to react. This made the Mk14 particularly effective in intercepting enemy fighters and bombers, allowing Allied air forces to assert control over contested airspace. The combination of speed and agility kept pilots alive while giving them the upper hand in dogfights that might have been far riskier in older aircraft. One of the key innovations in the Mk14 was its engine, which provided more than just raw speed. The Rolls-Royce Griffon engine delivered improved torque and reliability at high altitudes, where many aerial engagements took place. This meant that the Spitfire could maintain peak performance even in thin air, giving Allied pilots an edge in the high-altitude battles that characterized much of the late war air campaign, coupled with modifications to the airframe, including strengthened wings and improved aerodynamics. The Mk14 was faster, more responsive, and capable of handling the stresses of modern aerial combat better than most earlier fighters. The aircraft's armament also made it a lethal opponent. Typically equipped with 420mm Hispano cannons and 2.50 caliber machine guns, the Mk14 could deliver devastating firepower in a single pass. This combination allowed pilots to engage both enemy fighters and heavily armored bombers with confidence, making it a versatile tool for multiple mission types. From dogfights over Normandy to intercepting Luftwaffe raids on Allied supply lines, the Mk14 proved its worth in a variety of combat scenarios, showing that speed alone is not enough without the ability to strike effectively. What made the Mk14 particularly significant was how it represented the evolution of the Spitfire, designed to meet the challenges of a changing war. As German aircraft improved, the need for a faster, more powerful Spitfire became critical. The Mk14 met that need, allowing Allied air forces to regain the upper hand in engagements against newer German fighters, like the FW-190D9, and even to challenge early jet fighters in limited situations. Its performance also had a psychological impact, reassuring Allied pilots that they had a machine capable of keeping pace with, and even surpassing, their adversaries. The versatility and reliability of the Mk14 made it a favorite among pilots. Its handling characteristics were familiar to those who had flown earlier Spitfires, meaning that transition training was minimal. Yet its performance envelope had expanded dramatically. This combination of familiarity and improvement gave pilots confidence in combat, allowing them to focus on tactics and engagement rather than struggling with the aircraft itself. It was fast, responsive, and deadly, qualities that defined the late-war Spitfire and cemented its legendary status. Ultimately, the Spitfire Mk14 demonstrates how continuous innovation can keep a fighter relevant even in the face of evolving threats. Its speed, agility, and firepower allowed it to dominate many late-war air battles, providing the Allies with a potent tool for maintaining air superiority. By combining technological upgrades with proven design, the Mk14 became one of the fastest and most effective piston engine fighters of World War II, leaving a legacy that endures as a symbol of engineering excellence, pilot skill, and aerial combat mastery. During World War II, both Axis and Allied powers constantly pushed the boundaries of aviation technology in an attempt to gain the upper hand in the skies. While operational fighters like the Me-262, P-51 Mustang, and Spitfire Mk14 dominated the battles, there was also a parallel world of experimental and record-breaking aircraft that sought to redefine what was possible in speed, altitude, and firepower. These planes were not always produced in large numbers, and many never saw combat. Yet their development pushed aeronautical engineering to new heights and laid the foundation for post-war aviation. One of the most fascinating aspects of these experimental aircraft was the ambition behind their design. German engineers, for example, were constantly seeking ways to counter Allied air superiority. The Me-262A2B, a specialized jet fighter-bomber variant, was equipped with additional rockets designed to intercept Allied bombers from a distance, combining speed with precision attacks. Similarly, the Heinkel He-219 was developed as a night fighter capable of high-speed interception, using radar technology and improved aerodynamics to hunt down enemy bombers under the cover of darkness. These aircraft were not just fast, they were the product of a strategic vision that tried to exploit every advantage that speed and technology could offer. The experimentation extended to unconventional propulsion systems as well. Some German projects, like the Messerschmitt Me 163 Comet, used rocket engines instead of traditional piston or turbojet engines. This gave the Comet an extraordinary climb rate and top speed that far exceeded conventional fighters, allowing it to intercept Allied bombers almost instantly. However, the extreme speeds and volatile rocket fuel created enormous risks for pilots, and the aircraft's limited endurance meant it could only make brief sorties before returning to base. While not practical for large-scale deployment, these designs represented a leap in aeronautical thinking, showing that engineers were willing to explore radical solutions to gain a tactical edge. On the Allied side, experimental aircraft also pushed the envelope. Engineers tested high-speed prototypes and rocket-assisted planes to understand the limits of aerodynamics and propulsion. The lessons learned from these projects, even if the planes never engaged in combat, influenced post-war jet fighters, supersonic research, and the eventual development of missiles and space-bound vehicles. The experimentation demonstrated that wartime necessity could accelerate innovation, forcing designers to challenge conventional assumptions about what an aircraft could achieve in speed, maneuverability, and altitude performance. These experimental planes also had a psychological impact. Just the knowledge that new, extremely fast aircraft were being developed created uncertainty among enemy forces. Pilots had to consider that a new type of fighter could appear with capabilities far beyond anything they had encountered, forcing them to adjust tactics and approach missions with heightened caution. In many ways, the existence of these aircraft, even in prototype form, shaped the way air battles were fought and the strategies that commanders employed on both sides. Despite their brilliance, these experimental and record-breaking aircraft also highlighted the limits of technology when faced with practical constraints. Many designs were mechanically complex, difficult to maintain, and required highly skilled pilots. Fuel shortages, production bottlenecks, and logistical challenges often prevented these planes from having a decisive impact on the war's outcome. Yet, they remain a testament to human ingenuity, illustrating the daring and creativity that arise when necessity meets innovation. Ultimately, the story of these experimental aircraft is a story of ambition and vision. They pushed speed, engineering, and aerial strategy to unprecedented levels, inspiring future generations of pilots and designers. While they may not have achieved the fame or widespread use of operational fighters, their contributions to aviation technology were profound. They demonstrated that speed alone could redefine aerial combat, that innovation could change the rules of engagement, and that wartime pressures could accelerate technological progress in ways that continue to influence aviation even decades later. These planes remind us that the pursuit of speed and performance often drives some of the most remarkable achievements in history, leaving a legacy that stretches far beyond the battlefield.